want to integrate 5 cos 3x dx. Go to your log tables, to your integration page. So if you want to integrate cos, it'll change to sine. But it doesn't, like, it just says cos x. It doesn't say cos 3x. So you can have a look. There'll be a video on integrating trig functions, because, you know, the fact that there's a 3x here means that I'll have to think about that. So integration is the reverse of differentiation, and which that means that not only will the cos turn to sine, but I'll have to divide by the coefficient, or by the, well, it's the coefficient of the x in this situation, but it's the differentiation of the term here, the 3x. So it'll just turn to 5 sine 3x divided by 3, or you can say 5/3 sine 3x. Let's see. Like I said, if you want to go into more detail on it, there should be a video on it. Complete the table below. Well, these are radians, so I'm changing my calculator into radians. I need to get the function here is sine x. So sine of 0, pretty sure 0. And it tells me to do it 3 decimal places. So the sine of pi over 6. Pi over 6 is a half. So 3 decimal places, 0, 5, 0, 0. Pi over 3. 3 decimal places, 0.866. Pi over 2. That's 1.000. I'm only putting in the 3 decimal places because they did say correct 3 decimal places. That's all. And then the next one is the sine of 2 pi over 3. Uh, 5 pi over 6, sine of 5 pi over 6. And then the sine of pi, pretty sure, should be 0 again. Sine of pi. Use the trapezoidal rule to find the approximate area of the region enclosed between the curve and the x-axis. So, going to my log tables, looking for my trapezoidal rule. What that is. Trapezoidal rule, I need to know what h is. In this situation, it seems to be pi over 6. Each of those are going up in 30 degrees. So that's 30, that's 60, that's 90, etc. So going up in 30 degrees, so pi over 6. So h is pi over 6 when you look at the diagram here. So we have pi over 6 divided by 2. y1 is the height of the first one, so the height of that is 0, plus the height of the last one is 0, plus 2 times the height of all the rest of them. Okay, so the height of all the rest of them is here. This is what I was doing out. You know, the y coordinate is sine of 0, sine of pi over 6, etc. So I have 2 times the height of the rest. So we've done the height of this, we've done the height of this. We just need to do the height of the rest of them. 0.5 plus 0.866 plus 1 plus 0.866 plus 0.5. Which should be able to just throw that into the calculator. So 5/6/2, and I want to multiply that by bracket 0 plus 0. I don't need to put that in, but I'm just showing you that I'm entering it in exactly. 0.5 plus 0.866 plus 1 plus 0.866 plus 0.5, close your brackets. And I have 1.58. I'm going to write down the whole thing. It doesn't say to round off there, I think. 1.58755148 units squared. Use integration to find the actual area of the region above. Well, this is great because I should actually get an answer close to this if I'm right. So integration finds the exact area from 0 to pi, integrating sine x dx. So that just means in terms of x. So integrate sine, let's go back to this, I'm pretty sure it's cos, but I want to be sure. If you integrate sine, you get minus cos. So it's minus cos x, and I'm subbing in 0 up to pi. So minus cos pi minus, so I'm subtracting, minus cos 0. Again, I should be able to throw that into my calculator. So that's minus, what is the cos of pi? Alright, so that's that minus, cos of pi is minus 1. Minus, and then minus, what is the cos of 0? I think it's 1 again. Okay, so that's minus minus 1, which is plus 1, minus minus 1, which is plus 1, so 2. So 2 square units. 2 square, or units squared maybe. Same thing. Yeah, close enough. You could check that to see if, like, I think they're close enough anyway. For me to think that I'm on the right track there. The inflated ball is kicked into the air from point on the ground. O is the origin, x and f of x, or x and y, approximately describes the path of the ball in the air. So there's my function. Find it when the ball is on the ground. So that means the height is 0. So f of x equals 0. There's loads of ways to do this, but this is probably the most straightforward. So I'm going to take out the x in common. I end up with minus x plus 10 equals 0. Let each factor equal to 10. X is 0 minus x plus 10 equals 0. So x is equal to 10. Find the values of x for which the ball is on the ground. There they are. Find the average height of the ball. So I'm going to get my average height formula. And then integrating minus x squared plus 10x dx. And in this situation, during the interval from when it is kicked until it hits the ground again, so from here to here, so from 0 to 10. So I have 1 all over 10 minus 0. I need to integrate that, which gives me minus x cubed over 3 plus 10x squared over 2. You can put in your plus c. And I'm subbing in that. So 1/10. And then minus 10x cubed divided by 3. So I'm going to try and put all this into the calculator. Sorry, so minus x cubed, and I'm subbing in 10 minus when I sub in 0. So I'm going to sub in 10, so that's 10 cubed all over 3 plus 10 times 10 squared all over 2. The plus c's will cancel out. And I'm going to subtract when I sub in 0, so minus. So 0 cubed divided by 3 is 0, so minus 0, whatever. Plus, yeah, that's 0 as well. So actually would be just subtracting 0. So that's 500 over 3, so 1/10 times 500 over 3 times the 10th is 50 over 3, or 16.6 recurring, height units, meters. And then the slope of the tangent to the curve. So this gives me the formula for the slope of the tangent to the curve. If you have the formula for the slope of the tangent to the curve, integrate it and you should get the formula for the curve. So integrate 2x minus 2 turns into 2x squared over 2 minus 2x power 1 over 1 plus c. And the curve cuts the x-axis. So now this is the formula for the curve. And we can cancel that out. So we have x squared minus 2x plus c. We need to figure out if we can find a value for c. And what do I know? This is the formula for the curve, and the curve cuts at minus 2, 0. So I'm going to put it, so y equals, so I'll just write y equals x squared minus 2x plus c. So instead of y, I'm putting in a 0. Instead of x, I'm putting in a minus 2. So 0 is equal to minus 2 squared minus 2 times minus 2 plus c. And that gives me 0 is equal to 4 plus 4, which is 8. C is equal to minus 8. So formula for the curve is f of x equals x squared minus 2x minus 8.